Well, as you can see, we're doing this program from my home in Selsey, where I've got an old thatched house within sound of the sea. And in the garden, I've set up my two telescopes, the big ones, a reflector inside a run-off shed and another one inside a dome. And it's from here that I carry out my own observational work. But you know, there's a tremendous amount to be said, particularly in this year, 1969, which is always going to be remembered as the year of space, and above all, the year when men first knew that they could go to other worlds. And of course, the first target for manned space exploration was the moon. And in May this year, Apollo 10, from which these pictures were taken, made the final preparations for a manned landing, when the module was taken down to within 10 miles of the moon's surface. And the pictures sent back were absolutely amazing. And all this led on to July the 16th, 1969, when Apollo 11 was launched from Cape Kennedy.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
Okay, we got a roll program.
Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on proper heading.
It's lifting beautifully into the sky. A typically beautiful Saturn V launch. What a roar. A great flame over twice the length.
And these were the final moments as Armstrong and Aldrin came down toward the Sea of Tranquility, ready for the first lunar landing.
30 seconds. Contact light. Okay, engine stop.
The first man to step out onto the moon's surface was Neil Armstrong. And here you can see the huge shadow of the module.
Surface is fine and powdery. I can pick it up loosely with my toe.
And here's the module standing on the moon's surface, where it stayed for a total of 22 hours. This picture of Armstrong and Aldrin was taken by an automatic camera in the module, and they're on their way to putting up the American flag. And here's the shot of the year, or any year. Taken by Neil Armstrong, it shows Colonel Edwin Aldrin on the moon's surface, and it sums up the achievement of Apollo 11. But one of the most dangerous parts of the mission was getting the men back from the moon to the relative safety of the command module. And here you can see the module maneuvering prior to making the final link up. And there's an entrance through which the astronauts had to crawl. The whole thing is very difficult and very dangerous indeed.
As we suspected, it's even perhaps easier.
And as always with American space shots, Apollo 11 came to a watery end as the astronauts were picked out of the capsule and hurried off to a long period of quarantine. Since then, Apollo 12 has also gone to the moon and back. And although there were some minor disappointments, such as the failure of the television camera, there's no doubt that the mission as a whole was most successful. One American scientist has estimated that it will yield at least 1,000 times more scientific information about the moon than Apollo 11 did. And here's a measure of Apollo 12's success in landing within 200 yards of the unmanned Surveyor 3. And I think the Apollo shots in 1970 should prove really interesting. But, of course, let's remember that the Americans weren't the only ones in space in 1969. This is a Russian rocket being transported for a Soyuz manned spaceflight. You can see the huge nozzles underneath, which are used to steer the rocket during its flight in space. The Russians have just released this remarkable film of the mission of two spacecraft, Soyuz 4 and Soyuz 5, and so we're going to show it to you now in some detail. There had been two previous Soyuz missions. The first was in April 1967, when, unfortunately, Vladimir Komarov was killed on landing. And then in October 1968, when the spacecraft had been redesigned. On this occasion, two Soyuz craft were sent up. One of them was unmanned. There was a cosmonaut in the other, and he linked his craft with the unmanned one. Since this had been very successful, it was thought very natural that the Russians would follow it up, and they did. You can see here the characteristic shape of the Russian rockets, quite different from the American Saturn V, and of course a great deal smaller. When all the preparations for blast-off of Soyuz 4 had been completed, the pilot of the spacecraft was driven to the launching site, and here is Vladimir Shatalov actually heading for his first space flight. You can see the whole thing's very much more informal than the Americans are with Apollo. Unlike the Americans, Russian astronauts don't wear their spacesuits during the launch, and in fact they only wear them if they have to leave the pressurized compartment of the spacecraft to go out into the vacuum of space. And here you can see Shatalov at the top of the tower waving to his friends and colleagues below. Soyuz 4 was launched on January the 4th, 1969. Once he'd reached orbit safely, Colonel Shatalov sent back television pictures. And here's the Russian mission controller. Shatalov showed the equipment in the spacecraft, and cine pictures were also taken in flight. At this time, there was a great deal of speculation around the world as to the purpose of the mission. No information had been released about it, following the usual Russian practice, although personally I'm pretty certain that this is merely another step in their planned objective of putting into orbit a manned space station. On the following morning, 3 more cosmonauts made their way to another Soyuz rocket at the same launch site. This was the first time that more than one man had been launched in one of these spacecraft, although the Russians had had previous experience of 3 manned flights with the Voskhod series. 24 hours after Soyuz 4, Soyuz 5 was launched. Here's an animation showing some of the Soyuz features. You can see the solar wings and the radio aerials, which open out immediately after the craft is released from the rocket's nose cone. The solar panels are a special feature of the Soyuz, which is orientated so that the panels lock onto the sun, as you can see in the diagram. Once that happens, they supply enough electricity to charge up the spacecraft's power system. But the word Soyuz means union, and it's an essential feature of these craft that they can be linked together in space. Once close enough, one of the two turns around to face the other. This is the active one, while the other remains in the same position. The actual docking itself is carried out very gently indeed, and with very delicate movements made by the controlling rocket motors. It's basically the same technique as the Americans developed to dock their lunar excursion module with the command module of Apollo. Once the 2 Soyuz spaceships are locked together, they make up an orbiting space station controlled from one of them. This is what Soyuz 4 and 5 did, and here are actual television pictures of the docking taken from Soyuz 5, which was the passive ship during the operation. You'll be able to see the sensing probe guiding the two together, and finally a slight shudder as the 2 ships are actually locked firmly together. The connection between the twin ships includes electrical and telephone circuits, so they both now behave as one spacecraft, and in fact, you know, to all intents and purposes, you can say that for the moment they are one spacecraft. After the docking, 2 of the 3 cosmonauts in Soyuz 5, Yevgeny Krunov and Alexei Yeliseyev, put on their spacesuits, went through the forward compartment, and came out into space. They spent about an hour there, carrying out various experiments. This was the first time that a spacewalk had actually been tried from a Soyuz, and here you see television pictures of one of the 2, I think it's Yeliseyev, handling a line from the other. But the unique thing about this spacewalk was that they returned not to Boris Volynov, the commander of Soyuz 5, but to Shatalov in Soyuz 4. So they changed ships. And here they are, coming into the main control compartment, having taken off their spacesuits in the forward compartment. This, obviously, was quite a reunion, and they were naturally very jubilant about the whole adventure. It was the first time that such a transfer in space had ever been achieved. The 2 newcomers brought Shatalov letters from relatives and newspapers with headlines of his flight. Remember, they left Earth a day after he did, and according to one report, they all celebrated with 3 tubes of blackcurrant juice. After the separation of the 2 craft, Soyuz 4 was the first to come down. And you can see in this animation how the craft splits into 3 parts, the middle one of which, containing the cosmonauts, makes the descent through the atmosphere. It has to withstand great heat, and at about 5 miles up, the main parachute opens. Russian spacecraft come down on the land rather than the sea, and this, of course, makes the whole rescue procedure very much easier, because you haven't got to involve rafts and things of that nature. Later on in the year, the Russians made a group flight of 3 Soyuz craft, which was certainly another stage towards an orbiting, manned space station, which they stated as being one of their main aims. And I've no doubt that we're going to have many more interesting manned space flights from the Russians in the near future, certainly before the end of 1970. Well, I'm afraid I haven't got any space rockets in my garden, but I have got a couple of big telescopes, and the largest of them is a 12.5-inch reflector in this runoff shed. Shed's very easy to operate. It has the great advantage you can get your telescope working quickly. This is what we call an alt-azimuth mounting, and you can see you can swing it round anywhere, and it is very convenient from that point of view. But it hasn't actually got the drive on it, and so most of my planetary observing is done with the other telescope, which has got the equatorial mount and is in a dome a few yards away. Well, this is a perfectly conventional telescope with an 8.5-inch mirror, and it's on a massive equatorial mount, as you can see, so it's very suitable indeed for observing the planets. Well, this year, earlier on, Mars was quite nicely placed, and I made drawings of it with this telescope and my other one. And oddly enough, in some ways, it's a great deal better to make drawings of planets with this kind of telescope than it is to try and take photographs, because your photographs need a time exposure, and they're bound to be blurred. And with a drawing, you can take advantage of the bits of good seeing. Mars, of course, is out of the way now and won't be back for some time. But Venus is a different kind of world to observe, because oddly enough, you have to do it basically in the daytime. So you have to have a telescope which can find it without being able to see it. Venus, of course, is a very peculiar kind of world, and when you look at it from Earth through any telescope, all you can see is the top part of a layer of cloud. You can't see through to Venus's surface at all, simply because the cloud never draws back. And so before the space age, we knew very little about it. But, of course, rockets have now been there, and earlier on this year, 2 Russian ones, Venera 5 and 6, actually parachuted down through Venus's atmosphere and landed on the planet, sending back signals as they did so. And what they sent back is not very encouraging. It seems now that Venus's atmosphere is made up almost entirely of the heavy gas we call carbon dioxide, but the surface temperature is so high that life as we know it just couldn't exist there. And also, the atmospheric pressure is immense. There's so much atmosphere that it would squash you down. So altogether, I think we've got to agree now that Venus is not a world where anything can live, and our chances of going there in the foreseeable future are very, very slim. So that brings us back to Mars, the only other planet within range at the present moment. And Mars, which was nicely visible earlier on this year, has always been regarded as the planet more like the Earth than any other. And until very recently, it was thought very likely indeed that life did exist there. I don't mean human or animal life, but certainly plenty of vegetation. But now, alas, from the results of Mariner 6 and 7, this doesn't seem nearly so likely. And it does seem that those dark areas, which had always been thought were due to vegetation, are more likely to be due to shifting dust. And even those white caps covering Mars's poles are solid carbon dioxide instead of water ice. And this, you know, really is most discouraging. And I'm bound to say that I think now that the chances of our finding life on Mars are pretty slim. But even so, it must be the first world to be reached after the Moon, simply because all the others are very much worse. Well, our knowledge of Mars now depends very largely upon the Mariner probes, and the latest 2 were Mariners 6 and 7. And so if we go indoors, I'd like to show you some of the results that Mariners 6 and 7 sent back to us. These mariners are very special craft. They were sent within 2,000 miles of Mars, and believe me, that's pretty good shooting. But of course, it takes a great deal of rockets to launch a fairly small probe, as you can see. And the probes themselves, the mariners, are rather curiously shaped. And of course, they use solar power so they can send back their signals. One thing you can't do, though, when you're going to send a rocket to another world, is to send it straight across the gap, straight across the shortest part, so to speak. And by the time you've finished, you have to send your probe halfway round the sun before it gets as far as Mars. It has to go in a rather special kind of path, known as a transfer orbit. At this stage, I'm going to introduce you to an old friend of mine, Eric Eilert. And he makes many of these models that we use on the Sky at Night programs, and he's made a special one now to show us just how the mariners move.
This is a model to show the flight path of the Mariner spacecraft between the Earth and Mars. Here's the Sun in the middle of the diagram, here's the Earth, and here's Mars. The Earth is orbiting around the Sun, and in this position, because the Earth is orbiting at twice the speed of Mars, it's catching Mars up. At this point, the Mariner spacecraft is launched. It flies between the orbits of Earth and Mars, gradually slowing down until it gets to this point here. At this point, it slows down quite considerably until it intersects the orbit of Mars here.
Thank you, Eric. The pictures sent back from Mariner 6 and 7 were really remarkably good. They showed Mars in close detail, and in particular, they showed the Martian craters. We did know that craters exist because they'd already been revealed by the earlier Mariner pictures of 1965, but these new pictures showed them a great deal more clearly. A few weeks ago, I went over to Pasadena in California, and there I talked to the man who's been in charge of all the photographic side of the Mars experiments, Dr. Robert Layton. Looking at these photographs in general, all those you got from Mariner 6 and Mariner 7, what to you is the most significant and interesting thing about them?
Well, that's very difficult to say because if one makes up any kind of a list of the possible uses and features of interest for which the pictures would be useful, it's such a long list and it covers such a broad range of scientific fields that you get a different answer from different people. Certainly the profusion of craters and their size distribution, one gets the impression all the craters are the same size, about 30 kilometers in size, and there seems to be a dearth of small craters. That's extremely interesting. The behavior of the polar cap, with the polar cap edge disappearing within a couple of degrees of latitude, which indicates very small slopes there. The scouring out of the bottoms of the craters very close to the south pole of Mars. The south pole of Mars is just down here outside this picture. Is a very interesting phenomenon we have some ideas about, but not complete answers. This, incidentally, is our only indication of possible life on Mars. You see in this picture there's a footprint, and this is an enlarged view. The inhabitants of Mars are large, if nothing else.
Yes. And one last question, Dr. Layton. Are these pictures you've got from Mariner 6 and 7 better than you dared hope before you launched the probes?
Well, that's a little difficult to say also. Certainly the close-up pictures from Mariner 7 exceeded our fondest expectations. The other ones are about what we expected.
Thank you very much indeed, Dr. Layton.
You're welcome.
The Mariners have been extremely successful, and the Americans plan to get a man on Mars sometime between 1985 and 1990, and I'm sure they'll do it. But what about the Russians? They're interested in this too, even though they haven't so far had much success with their Mars probes. But they are very keen on looking ahead. And we've got here a rather interesting film from Russia which shows what they think of Mars and what is likely to happen there in the future. The first stage in the exploration of Mars, according to the Russians, is going to be a flight over the planet's surface, taking various measurements and photographs. And here you can see the instruments rotating in the nose cone of the spacecraft. And notice the heavily cratered Martian surface. This, I may say, has proved to be a very accurate reconstruction. A few years after the orbiting trip, an unmanned probe would be sent to the planet. This would land on the Martian surface, and it's very similar to the probes which have been sent to the moon. The instrument package has a number of different experiments. Here you see a sample of Mars dust being sucked up and then analyzed by examining its effect upon various chemicals. This should establish whether or not there are any bacteria in the Martian soil. samples could be obtained from a greater area around the spacecraft by ejecting a piece of sticky tape and drawing it back into the instrument package. All the results, of course, will be radioed back to Earth. Then, one day, the great moment will come when men land on the red planet. We've already seen from the moon flights that men can achieve far more on these explorations than unmanned probes could ever do. This is an imaginary sunrise on Mars, and you can see the wisps of steam rising from the surface. This might explain the occasional obscuring of some of the Martian features. The Russians, then, also have depicted strange, glinting rocks in the sunrise. Oh, yes, man's undoubtedly going to find a great deal to fascinate him on this new and exciting world. Sooner or later, there will be a manned colony on Mars. And here you see the domes which will provide the conditions necessary for life. The Russians think there will also have to be huge water towers, possibly pumping water up from far below the surface. It all looks fascinating, but I wonder what life in a Martian colony is really going to be like. We've got to remember, though, that both Mars and Venus are very close to us in the solar system. What about the planets out beyond Mars? Well, they're a very long way away. They're very cold, of course, because they're so far from the sun, and they're very different from the Earth. Consider Jupiter, a huge planet made up of gas, at least in its outer layers, with belts across it and with 12 moons going round it. Beyond Jupiter, Saturn, the planet with the rings. And beyond Saturn, two more gas giants, Uranus and Neptune. And then, right on the edge of the solar system, that strange little world Pluto, about which we don't know very much. Quite clearly, we can't send expeditions out that far because these planets are just too far away and they are too inhospitable in any case. But oddly enough, there is a chance that before very long we shall get television pictures back from them. It so happens that toward the end of the 1970s, these giant planets are so lined up that we can use the gravitational pulls of these worlds to hurl a rocket from one to the other, so to speak. This is known as the Grand Tour. And if it's not done in the next few years, well, there won't be another chance for more than 170 years. So plans are already being made. And when I was out in Pasadena, I asked Dr. Pickering what these plans were.
One possibility, for example, is that we will pick 3 planets rather than 4, because it turns out that the actual trajectory past the planet Saturn gets a little bit, shall we say, confused with Saturn's rings if we try to do all 4 planets. So rather than that, we will probably do a 3-planet mission, for example, a Jupiter, Saturn, Pluto mission, and then a Jupiter, Uranus, Neptune mission. And in this way, we will get all the planets, and we will do these 2 or 3 years apart. These missions will carry spacecraft which are based on the Mariner spacecraft. They will be a little larger. They have to exist for longer periods of time. They will have to operate with some other source of power supply. For example, we will be too far away from the sun to use solar cells effectively at those distances. So we will use some radioactive material for a power source.
How long will one Grand Tour take?
Again, it depends on the precise mission, but let's say in the general range from about 7 to 10 years. And so this means that we have to operate for much longer periods of time than we've been used to doing so far.
Well, it ought to work, and I hope it does. But what about going further still? What about travel beyond our solar system? If you look up into the sky on any dark night, you will see thousands of stars, and all these stars are suns in their own right. But I don't think there's any chance at all that we're going to be able to send rockets out to them. Of course, they're much too hot to land on, but many of them may have other planets going round them, other Earths, if you like. I'm sure they have, and I'm also sure that many of these other Earths are inhabited, some by people who know as much as we do, and others by races who know a great deal more. But the distances involved make it quite impossible for us to send rockets to them, and I don't think we shall ever be able to do that. If we are ever going to contact those other civilizations which must exist, it's got to be done, I think, by some method about which we know absolutely nothing at the present moment. And I suspect we're just about as far away from that kind of thing as King Canute was from television. And yet, you know, in spite of that, 1969 has been a most exciting year, and the years that are going to come are going to be even more exciting than that. Because in the next few years, we're going to have further rockets sent into space, we're going to have more probes to the Moon, Mars, Venus and beyond, and we're going to learn a great deal more about the universe in which we live. Personally, I'm going to go on watching and listening from my observatory here at Chelsea, and all over the world, astronomers with far greater knowledge and far better equipment than I have will also be very busy. But I suggest, you know, that if you've got a telescope or even a pair of binoculars, you go out and have a look at the moon and Mars and Venus and the stars, because they become so much more fascinating when one learns how to find them and knows a bit about them. The future, certainly, is going to be exciting in every way. And yet, somehow, I don't believe that anything is quite going to equal that tremendous moment on July the 21st, 1969, when man first stepped out onto the surface of the moon.
It's one small step for man, one giant leap